proving tan-chord theorem. Okay, this is Euclidean Geometry, part 17 of 25. We are going to prove tangent-chord theorem. Okay, so you are given this. You are required to prove, okay, RTP, required to prove this angle MNP, okay, MNP. This angle is equal to the angle PRN. This angle, okay. Let me show you how you can prove this theorem easily. Whenever you are required to prove the tangent-chord theorem, always focus. Let me show you. Always focus on this part where you have your angles that you have to prove. Always focus on this part. What you are going to do is to create a 90-degree angle. Okay, so let me do this. You have to focus on this part and on this part. Try to create a 90-degree angle. So you have a tangent. How can you create a 90-degree angle? Remember the tangent radius theorem. So you need to recall these theorems. Okay, you have this theorem, angle in semicircle or angle subtended by a diameter. Please check lesson 13 of 25 and you have to recall this theorem, angles in the same segment. Please check lesson 14 of 25 and you have to recall this theorem, tangent radius theorem. Please check lesson 15 of 25. So you have to focus on this part. Okay, you have to try to create a 90-degree angle on each part. So from this part you have a tangent. You can use tangent radius theorem to create a 90-degree angle from the point of contact. Okay, so you are going to say construct diameter SN from the point of contact. You construct diameter SN. Okay, you can use different letters. Okay, the letters mean nothing. You can use different letters. So a tangent and a diameter, or a tangent and a radius, you are going to have a 90-degree angle. Okay, now let's focus on this one. Can you see? You have a diameter. So an angle subtended by a diameter is equal to 90 degrees. So you can construct chord SR. Construct chord SR. Now can you see this angle is equal to 90 degrees because this is an angle subtended by a diameter. You have diameter SN. So now let's do this. So name the angles that are required to be proved, N1 and R1. Okay, so this is N1 and this is R1. Now name the other angles, N2 and R2. Okay, the other angles. This one you call it N2. This one you call it R2. Can you see? N1 plus N2 is equal to 90 degrees. Okay, n1 plus n2 is equal to 90 degrees. So the reason is tangent radius theorem. Okay, this theorem from 15 of 25. You can also see r1 plus r2 is equal to 90 degrees. Okay, r1 plus r2 is equal to 90 degrees. The reason is angle in semicircle or angle subtended by a diameter. Okay, angle subtended by a diameter is equal to 90 degrees. So this is the reason, angle in a semicircle. Okay, so now remember this theorem from 14 of 25. Can you see? Let me show you. Can you see this arc? This arc SP. Can you see this angle R2 is subtended by this arc, and this angle N2 is subtended by this arc as well. Okay, R2 and N2, can you see they are subtended by the same arc? You can follow the lines. Okay, you can follow the lines. So because the two angles are subtended by the same arc, these two angles are equal. Okay, so N2 is equal to R2. Okay, please check lesson 14 of 25 so that you can understand this. So N2 is equal to R2. The reason is angles in the same segment. Okay, angles in the same segment or angles subtended by the same arc. Okay, so this angle is equal to this angle. Now, so from this, N2 is equal to R2. Okay, N2 is equal to R2 because of this. So can you see, since N2 is equal to R2, automatically N1 is equal to R1. Okay, let me show you. So for example, if N2 is equal to 5, because N2 is equal to R2, it means R2 is equal to 5 as well. This is an example. Okay, this is an example. So what is N1 equal to? N1 is equal to 85. Okay, 85, because 85 plus 5, you have 90 degrees. Even in this case, R1 is equal to 85, so that you have 90 degrees. So can you see, N1 is equal to 85, R1 is also 85. I can show you another example. Let's say N2 is equal to 30 degrees, because N2 is equal to R2. It means R2 is also 30 degrees. So what is n1 equal to? So that you have 90 degrees. Do you agree? n1 is equal to 60 degrees, because 60 plus 30, you have 90 degrees. Even r1 60 degrees, because 60 degrees plus 30 degrees, you have 90 degrees. This is because n2 is equal to r2. Okay, since n2 is equal to r2, okay, automatically n1 is equal to r1. Okay, so n1 is equal to r1. Okay, so can you see n1 is angle MNP. Okay, n1 is the angle MNP, which is equal to r1. r1 is the angle PRN. Okay, so we have proved